Good afternoon, class. Here's pre-calculus practice test, module 1, covering chapters 1 and 2. Here's chapter 2, linear functions, the first part. Again, reminding you about the pledge whenever we take the exam. Okay? In short, you take the exam on your own. All right, recall chapter 2, linear functions, difference, quotient, f of x plus h minus f x or minus f of x over h, and h can't be 0. In short, the average rate of change of y with respect to x, or the slope that we have seen. So dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. So domain refers to all x along the x-axis that are acceptable, and range refers to all the y coordinates. So for example, if you look at this graph, you try to lay it over the x-axis, which portion it covers. That's the domain. Try to lay it over the y-axis, which portion it covers. That's the range. So, relation, a set of ordered pairs. Those are definitions. Domain, the set of all input values, x values independent variable for a relation. Range, the set of all output values, the y values dependent variable for a relation. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range, which gives rise to the VA, vertical line test. If a vertical line, if a VLT, if a vertical line can be drawn so that it intersects a graph at more than one point, then the graph doesn't represent a function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. Horizontal line test, HLT. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. In other words, VLT, the x coordinate can't repeat, it becomes a function. HLT, the y coordinate can't repeat either, so it becomes a one-to-one function. Find the domain of each function. You're dealing with a rational function. You set the denominator equal to 0 and you exclude that. 2x minus 1 is 0 results in x equals 1/2, which means the domain would be all real numbers except 1/2. So you can say x is not equal to 1/2, or better yet, this is the interval format. The domain is from negative infinity to 1/2, parentheses, union parentheses, 1/2 to infinity. With the parentheses, you're excluding the endpoint, namely 1/2. F of x squared of 5x plus 4. Because the index is even, remember, when we don't write the index, is 2. Then 5x plus 4 must be larger than or equal to 4. Move it and divide by 5. So x must be larger than or equal to negative 4/5. So it's from negative 4/5 to infinity. F of x equals x squared. The domain is all real numbers. Why is that? It's a polynomial function of degree 2. Any polynomial. The domain would be all real numbers. Cube root of x. What happens when the index is odd? The domain is all real numbers. Why is that? Root function with odd index. So just to give you an idea, cube root of 8 is 2. Cube root of -8 is -2. So there is no restrictions. What about this one? You set the denominator equal to 0 and you exclude that. X squared minus 1 equals 0. X is plus minus 1. So the domain is all real numbers except those two numbers. So this represents the domain, everybody. How do you write them? In an interval notation. Minus infinity comma -1, union -1 to 1, union 1 to infinity. F of x is 2/3 x plus 2/3 x plus 7 are real numbers. Why is that? It's a linear function. It's a polynomial of degree 1. Determine if the graph represents a function, a one-to-one function, and find the domain and range of each using interval notation. So if you look at this one, is this a function? Yes, it's a function, and it's a one-to-one function because it passes a vertical line test. That means no vertical line crosses it more than once, and it passes a horizontal line test. So the domain would be all possible values of x. If you lay this along the x-axis, it covers from here to here, from 2 to 8. 2 is not included. So parenthesis 2, comma 8, bracket, and now lay it along the y-axis. It covers from here to here, from 6 to 8. Again, 8 is not included. So this one corresponds to this, and anywhere in between is covered except the top. What about this one? Is this a function? Yes. Is this a one-to-one function? No. Notice it passes any vertical line test you can come up with, but just as an example, this is a horizontal line. So these two have the same y coordinate. So it fails the HLT, therefore it is not a one-to-one function. What about the domain? Break this and put it along the x-axis. What does it cover from here to here? Notice this covers here and this one here. So from -3 to 2, -3 is included, 2 is not. So bracket over here, parentheses. Now lay this along, break it along the y-axis. It covers from here to here, from -5 to 4. Brackets in both cases, because the endpoints are included. Is this a function? Of course not. Is this a one-to-one function? Look at the vertical lines, many of them, or horizontal lines, many of them. So it's not a function. It's not a one-to-one function, but we can find the domain by laying it down around the x-axis. So it goes from here to here, from -4 to 0, and the endpoints are included. Lay it over the y-axis. It covers from here to here, 0 to 4, and the endpoints are included as well. Given the function f of x equals 2x plus 1, find and simplify f of x plus h minus f of x over h. This is the difference quotient. So reminding everybody, rate of change, the difference quotient, delta y over delta x equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y, or f of x with respect to x, over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. So if you have a curve and you connect 2 points, one is P, one is Q, connect them the blue line to calculate the slope, you have the coordinates, you can do that. Now, there are different ways of writing it. You can write delta y over delta x. If you look at this one, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, that's one way to write it. If you call this a and f of a, b and f of b minus f of a over b minus a, you can call it f of x minus f of a over x minus a if this is just x. Or if this distance is h, then this rise is f of a plus h minus f of a over the run, which is h. And this is very important in calculus, okay, everybody? I want you to know that. So that's why we want f of x plus h minus f of x over h. In calculus, we take a limit of this expression and becomes the derivative function. So we want to evaluate this. And what happens, it's important to be able to evaluate and simplify this. So obviously, f of x is itself, h is h. What is f of x plus h? Replace the x with x plus h. 2 times x plus h plus 1. You want to simplify this? Distribute 2x plus 2h plus 1 minus 2x minus 1. So we get 2h over h, which is equal to 2. So pretty straightforward, everybody. And it's important to know we have various ways of writing the same thing, rise over run, rise over run. So they all mean the same thing. Algebra of functions. F plus minus g of x is f of x plus minus g of x. The sum function, the difference function, fg is f of x times g of x, and f over g is f of x over g of x. Needless to say, the denominator can't be 0. Given that the domain of f is a and the domain of g is b, the domain of all of them is a intersection b, except the last one. It's even smaller. It's the same thing. X is an element of intersection b, but g can't be 0. Composite function. F of g is f of g of x. G of f is g of f of x. So g maps x to the g, and then f of g maps x to f of g. In other words, g of x is being mapped to f. So this represents the composite function, and therefore the domain of a composite function f of g of x refers to the set of all possible input values, x values, for which the function is defined. The set of values from the domain of the inner function, for example, in this one, the inner function is g of x. In this one, the inner function is f of x. So in this case, okay, the inner function g of x, so let's make sure we are looking at this for now. That also produce outputs within the domain of the outer function f of x. When composed, the input value must be valid for both functions involved in the composition, with the output of the inner function needing to be valid input for the outer function. In other words, inner function restriction. The domain of the composite function is always a subset of the domain of the inner function. So what that means is that find the uh, domain of the inner function, in this case g of x, and then see if there's any more restrictions. Then output check. For a composite function f of g of x, you need to ensure that g of x, the output of the inner function, is within the allowed input of function of f of x, because f of x itself may have a restriction. If it has no restriction, if f has no restriction whatsoever, whatever the domain of G is, will be the domain of their composite function. For G of F, if G has no restrictions, whatever the domain of F is, becomes the domain of both of them. And so having said that, finding the domain. To find the domain of a composite function, first find the domain of the inner function, then restrict the domain further by considering which output of the inner function are valid inputs for the outer function. So that's how it works, and we will look at examples later on. But for now, let's start with the function f of x equals 2x squared plus 1 and g of x equals 3x minus 5. We want to find their composite function in the following manner, f of g of 2. And by the way, you can find f of g of x and put 2 in there, or just f of g of 2, first find g of 2. So g of 2, plug in 2. 3 times 2, 6 minus 5 is 1. So let me just write it in case this is 6. So that's very straightforward, everybody. Now, f of g of 2 would be f of 1, which means put the 1 into the function f. 2 times 1 squared plus 1. 1 squared is 1 times 2 is 2 plus 1 is 3. What about f of g of x? Replace this x with the g function. 2 times 3x minus 5 quantity squared plus 1. Reminding you of some of the identities, a plus minus b squared is a squared plus minus 2ab plus b squared. A squared minus b is a minus b plus b. So we use, in this case, a minus b squared. So you square this one. So just to write all the steps for this one, you get 3x quantity squared minus 3x times 5 plus 5 squared. That's what you get. And so this is 9x squared. This is minus 2 times. I meant 2 times 3x times 5. And that 6x times 5 is 30x with a negative in front plus 25. You distribute the 2. 18x squared minus 60x plus 50. You add the 1, you get 51. By the way, you could evaluate this at 2 and get the same number. So plug in 2 and it must give you 3. You can try it. Now we want to look at g or f of x. That means replace the x with f of x. Distribute, you get 6x squared plus 3. 3 and negative 5, they add up to negative 2. The final answer is 6x squared minus 2. GOG, that means g of x, which means replace the x with the g itself, 3x minus 5, and try to simplify. So what do we get here? 9x minus 15. And these two, they add up to minus 20. The final answer is 9x minus 20. We want f, we are continuing with the same question. We want to find f of negative 2, which means f of negative 2, which means we can find f of negative 2 first. So f of negative 2, you're going to replace this x with negative 2. This is 4. 2 times that is 8, plus 1 is 9. And therefore, we are looking for f of 9. So replace the x with 9. 9 squared is 81. 2 times 81, 162, plus 1 is 163. Determine if the function f of x and g of x are odd or even. So what was the definition of odd and even? Even function f of minus x equals f of x, which makes it symmetric with respect to the y-axis. Odd function f of minus x is minus f of x, which makes it symmetric with respect to the origin, by the way, w or t with respect to. So evaluate f of minus x, evaluate g of minus x. So f of minus x, replace the x with negative. So minus x quantity is going to still the same as x squared. So this is 2x squared plus 1, the same as f of x, and therefore it must be an even function because nothing has changed. Let's do the same thing for the g. Replace the x with negative x, and it becomes minus 3x minus 5. Now, is this equal to the original function? No. If it was, it would make it even. Is this equal to the opposite of that? The opposite of that would be minus 3x plus 5. The answer is no. So g of x is neither even nor odd. It's not equal to g of x, therefore it's not even. It's not equal to the opposite of that, therefore it's not odd. And so therefore g of x is neither. Find the average rate of change of each function on the specified interval where f of x is given as 3x in the interval of negative 1 to 1, reminding everyone of the rate of change, which simply put is the difference quotient. Delta y over delta x is f of x up to minus f of x of 1 over x up to minus x of 1. So it's rise over run, everybody. There is really nothing brand new here. Rise over run. Rise over run. Therefore, f of 1 minus f of negative 1 over 1 minus negative 1. Like f of b minus f of a over b minus a, or f of x up to minus f of x sub 1 over x up to minus x sub 1. There are so many formulas, and I want you to realize they all mean the same thing. Rise, change in y, over run, change in x. That's it. So plug in 1, and then plug in negative 1. So 3 times 1 minus 3 times negative 1. So what we have here, 3 plus 3, and this is 2, 1 plus 1. And so the answer is 6 halves or 3. What about this one? F of x is given as 2x minus 9 from 4 to a. So we want f of a minus f of 4 over a minus 4, according to the rate of change. So what is f of a? 2a minus 9. What is f of 4? 2 times 4 minus 9. And so you simplify these. 2a minus 9. This is 8 minus 9 is negative 1. With this one makes it plus 1, which is 2a minus 8. You can factor 2 from the numerator, and therefore a minus 4 cancel out. The final answer becomes 2. F of x is 3x plus 4 on 2 comma 2 plus h. So f of 2 plus h minus f of 2 over 2 plus h minus 2. Of course, the denominator becomes simply h. F of 2 plus h, 3 times 2 plus h plus 4 minus f of 2, 3 times 2 plus 4. Now, you really have to be very comfortable with this, because this is how differentiation takes place with definition. So we have 6 plus 3h plus 4. This is 10. 3 times 2, 6 plus 10. So we have minus 10. So the numerator, 6 and 4 and negative 10 go away. It's just simply 3h. H cancels out, the h in the denominator. The final answer is 3. Graphing techniques, transformations. So vertical and horizontal shifts, translation C is larger than 0. First, makes it easier to see the graph. We have a graph of y equals f of x. And the C is a number, is a constant that is positive. So f of x plus c shifts up by c units. F of x minus c is the same function, shifts down by c units. F of x minus c moves to the right by c units. F of x plus c moves to the left by c units. Compression, stretches, reflection, we are assuming C is a number that is larger than 1. So again, we have this basic function y equals f of x. So if C is larger than 1, C times f of x makes the y larger. So it's stretched by a factor of C in a vertical direction. If it's 1 over C, it is compressed. It shrinks by a factor of C, 1 over C in essence. Okay. If y equals f of cx, then the function is the graph of f of x shrunk by a factor of c in the horizontal direction, and if it's x over c, stretched in a horizontal direction. Normally, when we discuss trigonometric functions, they make perfect sense when we look at it. Y equals minus f of x and y equals f of minus x. If this is the function, y equals minus f of x, if you put the sign, negative sign in front of f of x, you're negating the y, it flips over with respect to the x-axis. If you put the negative in front of the x, it flips over with respect to the y-axis, or reflection with respect to that. The following function was graphed by applying transformation to a toolkit function, also known as essential function, also known as basic functions. Write the equation of a function that matches the graph. So just reminding everybody, what are the basic functions we should know the graph? A constant function, y equals b, or f of x equals b. A horizontal line. Identity function, y equals x or f of x equals x. A line that goes through the origin, f of x equals x. We should know the graph. Square function, f of x equals x squared. It's a parabola everybody is familiar. Cube function, f of x equals x cubed, looks like that. Domain is all real numbers, range is all real numbers, looking like that, goes through 0, 0. Square root function, f of x or y equals square root of x, looks like that. Domain and range are both from 0 to infinity. And finally, the cube root function, y or f of x equals cube root of x, looks similar to y equals x cubed, but it's a lot slower. Again, domain is all real numbers, ranges are all real numbers. So when you know the graph, it really helps. And so if I want to deal with this, I should know the absolute value function looks like a V shape, and the vertex, which is at 0, 0. Okay, so the vertex is at 0, 0. But this guy, the vertex is at this location, which is 3, negative 2. So that's the new vertex. And so it can give rise to the new function y equals a times the absolute value of x minus h plus k. This is h, this is k, everybody. Let me just write this. So y or f of x equals a absolute value of x minus 3 plus negative 2, or simply minus 2, because k is minus 2. So as you notice, we are almost done. We have everything except a. So how do you find a? Find easy points. You can see, for example, this is the x-intercept at 1, 0, the y-intercept at 0, 1. Those are the easy points. You pick one of them, and it will do the job. For example, if you pick this one, you replace the y with 0, x with 1. This is -2. Absolute value of -2 comes out positive 2a minus 2, and a becomes 1. Replace it. And you must check it. I mean, one easy way to check, you can check it with this point, or 0, 1 was not used here, right? So you can put 0, 1 here. If I put 0 here, I get -3. Absolute value is positive 3 minus 2 is 1, so that works. I highly recommend you try it with a couple of points, maybe this one also, because you want to make sure you haven't made a mistake. It doesn't take long. The following function was graphed by applying transformation to toolkit function, essential function, basic function, one of those functions, f of x equals x squared, square root of x, and etc. You have to know all the graphs, everybody. I can't emphasize this enough. In other words, these graphs that we have looked at, you got to be very comfortable with them. A graph tells you everything, the x-intercept, the y-intercept, the domain, the range, you name it. So write the equation of a function that matches each graph. So by looking at it, you can tell what it looks like. It's somehow looking like that. So the basic function that you begin with, it's y equals square root of x with the intercept that is at 0, 0. And now the intercept has changed to -3, -1. So that's the new vertex. There is a shift. So if this is the square root of x, you have a times square root of x plus k. And of course, in this case, -3 makes this x plus 3 minus 1, plus minus 1, or simply minus 1. This is h, this is k, this is plus h, if you want to go that route. All right, and so the reason we put the A, because there may be some sort of a stretch and we don't know that. So all we have to do, pick a pair and always go with easy one that you can come up with. Obviously, this is an easy point with coordinates -2, 0. So replace the x with -2. The result y or f of x must be 0. So this is 1, comes out as 1, a minus 1 is 0, and a becomes 1. If a becomes 1, here's the final answer, everybody. Now you have to check. For example, this point has coordinates 1, 1. If I put 1 here, I get 4. Square root of 4 is 2, minus 1 is 1, so that check. Definitely check your work. It doesn't take long, everybody. So you have to check your work. Just clear this because it's hard to see this. This one is a square root of x minus h plus k, and this is h comma k. So that should be pretty easy to follow. Again, we are familiar with various essential functions. So the following function was graphed by applying transformation to a toolkit function, come up with the answer. Just the same as the previous pages, we should know the basic functions. So we should know what this looks like. Obviously, this comes from the original parabola, which is y or f of x equals x squared with the vertex at 0, 0. However, this has a different location. The new vertex is located at -1, +2. And the formula is A, parentheses x minus h quantity squared plus k. So A times x minus -1 makes it +1 quantity squared plus k, that means +2. And now we pick a pair, any pair. So as long as we have the vertex, any pair, and of course, easy pair, this has coordinates 0, 1, plug in and find the missing A. So if I plug in, 0 and 1 is 1, 1 squared is 1, so basically you have A. So this one is, this entire thing is 1 times A. So if A plus 2 is 1, A must be -1. And if you replace it, you get this one. Notice, parabola that opens up, A is positive. Parabola that opens down, A is negative. In this case, more specifically, is -1. And it definitely works. Now, you really have to check. So pick any point that you haven't done yet. This might be more difficult because it's -2.5. This might be easier. So the coordinates are -2, +1. So I want to double check. This one has coordinates -2 and +1. So if you put -2 with 1 becomes -1 squared, becomes +1. This makes it -1 plus 2 is 1. So yes, that checks. You have to check. I can't emphasize this enough, everybody. So again, you look at the general shape and you figure out what you need to do. All right. We want to find the equation of a function that is finally graphed after the following transformations are applied to the function y equals x squared. So we start with this, which is a parabola that opens up. Now we want to shift it to the right by 3 units. So that means, let's call it f of x. F of x equals x minus 3 quantity squared. Now we're going to deal with this. Reflect about the x-axis. So you put a negative sign in front of the y coordinate or f of x. That means put a negative here. So now the new one, f of x, is minus parentheses x minus 3 quantity squared. And finally, you bring it down by 2 units. You bring it down by 2 units. That means you add -2. So f of x is minus parentheses x minus 3 quantity squared minus 2. That is the final action that takes place.